Okay, what I'd like you to do is for today is take out graphing trig functions, number 3. So we're going to practice. And what I want you to do is practice graphing y equals sine x. And the second one is y equals tan x. And the third one is y equals secant x. Okay, so go ahead and graph those 3 practicing. Okay, so you know where to place the points and the vertical asymptotes if they happen. Okay, and all that. Go ahead and pause your video and go ahead and do that. And then I'll show you the solutions to these. Okay, see you in a little bit. Okay, so as a review, I just made this little diagram to help recall, okay, why these points are the way they are, okay? So we're going around a circle with radius 1, and then the sine ratio is defined as, for this circle, the output for sine is defined as the y on this diagram over your r, okay? So that's why right here, sine of angle 0, which is the positive x-axis, that's where the terminal side would be, the y is 0, and the radius is 1, so 0 over 1 is 0. That's why that one's 0, okay? So it's not that I want you to memorize all these points, it's that I want you to have an understanding of where they come from. Because if you have an understanding of where they come from, then you can reproduce this, okay? And it's not just memorized and you get a wrong point and you don't know why you got a wrong point because it's just a memorized thing, okay? So try to understand where these are coming from, okay? All right, so over here, okay, why is it that we have vertical asymptotes at every pi over 2, okay, for tangent? Well, tan is y over x, right? And at every angle pi over 2, you're either on the positive y-axis or on the negative y-axis. Every angle pi over 2, okay, odd pi over 2, so pi over 2, 3 pi over 2, 5 pi over 2, negative pi over 2, negative 3 pi over 2, and so on, okay? You're going to land right here. And on those two points, your x is always 0. And the tan ratio is y over x, so you're dividing by 0. That's why you have a vertical asymptote, okay? Now, why is this part of the graph from 0 to pi over 2 up here above, okay? Well, 0 to pi over 2 is the first quadrant, right? And what do we know about x's and y's in that first quadrant, okay? They're both positive. So when you go to do the ratio of y over x, the ratio has to be positive. And that's why this is above, okay? Now, why is this part right here below? Well, from pi over 2 to pi, okay, that's in the second quadrant. That would put you up here in the second quadrant right here, all right? And what do we know? We know the x's are negative and the y's are positive, which would give you a ratio of negative, okay? From pi to 3 pi over 2, that puts you in the third quadrant right here, okay? And for that third quadrant, we know about that quadrant that x and y are both negative. So when you go to do the ratio of y over x, they're both going to be negative, which will end up with a ratio that's positive. And that's why from pi to 3 pi over 2, the graph has to be above, okay? Same type of rationale for the secant, okay? All right. At every pi over 2, okay, because secant is the ratio of r over x because it's the reciprocal of cosine, okay? So wherever x is 0, which is at every odd pi over 2, okay, you're going to have a vertical asymptote. And that's why we have vertical asymptotes here, 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 every odd pi over 2, okay? So 0 to negative pi over 2, why is that above, right? Angle negative pi over 2 to 0 is actually this fourth quadrant, okay? Because we have to rotate down here with a negative pi over 2 to 0, right? That this quadrant right here, we know our x's is positive, right? And our y's are negative, but our ratio is based on r over x. So since r is always positive, in this quadrant x is positive, the ratio r over x would have to be positive, and that's why this part is above, okay? And same rationale for this one, okay? From 0 to pi over 2 for every single trig function, if no transformation has happened, it's always going to be above every trig function, okay? Because in this first quadrant, everything's positive. X is positive, y is positive, and then r is always positive, okay? So from 0 to pi over 2, if there's no transformation that happened, all 6 trig functions have to be positive, okay, for the ratio, okay? All right, so that was just a quick overview, okay, of everything, all right? Okay, and then let's go to the lesson, all right? Today is May 1st, and we're going to talk about amplitude, period, and frequency, okay? Along with review of some transformations that we did a while back in the fall semester, okay? So when you see something like this, y equals negative f of x, okay? F of x is your y's, okay? So this is multiplying your y's by a negative value, which causes positive y's to become negative and negative ones to become positive. So that's going to be a reflection, okay? And it's going to be a reflection over the x-axis, okay? So when you see y equals like negative sine x or negative cosine x or negative tan x, that's going to cause a reflection over the x-axis, okay? So let's write that. So this is a reflection over the x-axis. Can't say that, all right? Okay, now for this next one, y equals f of negative x, okay? So you're multiplying your x's by a negative, okay? So what happens is the positive x's are now going to become negative ones, and the negative ones are going to become positive. So that's a reflection over the y-axis, okay? So this is, let's write reflection over the y-axis, okay? Now, since f of x is like your y, okay, this one, all right, a times f of x, that's multiplying your y values by a. So depending on what the size of a is, okay, if a is between 0 and 1, then that's going to cause a vertical compression by a factor of a, okay? But if a is bigger than 1, then it's going to cause your y's to become bigger, okay? Hence a vertical stretch by a factor of a, okay? So there's two things that can happen here, okay? If 0 is less than a is less than 1, okay, then that's a vertical compression or shrink. Some people call it a shrink by a factor of a, okay? And if a is bigger than 1, okay, that causes a vertical stretch by a factor of a, okay? And then the next one, okay, this b. Now, that's not what we're multiplying by because it's the reciprocal of it, okay? So I meant to do arrow there. Okay, so for this one, okay, it's not, it's you got to determine what the reciprocal of b is. So 1 over b, the reciprocal, okay? If that reciprocal is between 0 and 1, since we're multiplying by a number between 0 and 1, that's actually, we're gonna multiply the x's by that. That's gonna cause a horizontal shrink, okay, or a horizontal compression. So if 0 is less than 1 over b less than 1, okay, so if the reciprocal of this b is between 0 and 1, then that's going to cause a horizontal compression by a factor of 1 over b. So we're never really actually multiplying by b, okay? So this is a horizontal compression by a factor of 1 over b. The factor is what you're multiplying by, and that's the thing that determines if it's a horizontal stretch or compression, okay? Now, when we take the reciprocal of b, if 1 over b, if that reciprocal, when we flip it, if it's bigger than 1, okay, then that's going to cause a horizontal stretch because the thing we're multiplying is bigger than 1, okay, by a factor of 1 over b. Okay? All right. Let's talk about a few more things, okay? So that's the review of the transformations, okay? All right. So let's talk about some other things now. Okay, so last couple days we've been talking about this thing called amplitude, right? We've been doing it so it's just positive, okay? But whatever this a is, okay, that we're multiplying the function by, if you take the absolute value of it, that will cause it to be positive, okay? And that value is our amplitude, and it's always going to be half the height of the wave, right? So to get the height of the wave, that's the max minus the min, that'd be the height of it, and we're going to divide by 2 or take half of it, okay? All right, so we'll get the amplitude that way. I'm going to talk about it in just a few minutes in these bottom graphs down here, okay? And then Graphically, the period is the length of one full cycle of the wave, okay? So because of this 1 over b, we're going to be multiplying our x's by 1 over b, okay? And b, we're going to make this b right here become positive, okay? And then what happens by taking the absolute value, we make it positive, okay? And so we're going to take our normal period for sine and cosine and multiply it by 1 over the absolute value of b, which will be b, okay? And that will be our new period, okay? All right, because this is either going to get bigger or smaller, and so that's how we're going to change the period of it, okay? And then another thing, this is more in physics. You use this is frequency. Okay, I'm going to ask you the frequency of it, but really, in the big scheme of things, it's not that big a deal. I just actually include this because of physics. Okay, and mathematically, it's really not that important. So this isn't that big of a deal. Okay, but graphically, the frequency is the number of complete cycles in one unit. Okay, so from 0 to 1, how much of the wave do you see? Okay. So if the period is like, if the period is 2, let's say 2 units, okay, then how much of that would you see in one? Well, you'd see half of it. So if the period's 2, the frequency would be 1/2. It's always the reciprocal of whatever the period is, okay? And basically we're taking 1 and we're dividing by what the period is to see how many of these fit inside 1. Okay, it'll give you as a decimal, okay, like 0.3 or something like that as the frequency, and that would mean you see 0.3 of the wave. That's you could think of it as being percentages too, like what percent of the wave do you see, okay? All right, so that's frequency. I'm going to give you some examples and I'll show you how to do this, okay, in just a few minutes, okay? So let's go to the next thing. Okay, so right here, from this distance from here to here, okay, I'm going to draw this in. That distance right there is the wave height. And we can find it by taking the maximum value, like in this case 1, and subtracting the minimum value. So this has a length of 2 because 1 minus -1 would be 1 plus 1, which is 2, okay? All right, and then half that, which would be this distance right here, from here to here. Let me get a better pen. From here to here, that's what we're calling the amplitude, okay? And it's half of this wave height. So it's going to be, it's equal to the max minus the min divided by 2. And we've done that several times, okay? All right, and then the next thing I want to say is the period, okay? So the period is horizontally, how long it takes horizontally for it to start to repeat, okay? So from right here, my pens are getting dried up, okay? I guess I'm not using them enough, huh? Okay, so right here to here, that distance from a max to a max, it could also be a min to a min, okay? That is the period. That's how long it takes to repeat. Because once we get back up to here, it's going to go down again and it's going to start this cycle all over again, okay? So this is the period. Okay, now hopefully you recognize this graph, okay? This is the graph of y equals sine of x, okay? And we're going to use 5 points. This is why I'm labeling it the 5-point method, okay? It's these 5 points, okay? It's 0, 0. And we're going to use these 5 points to transform it, okay? Pi over 2 comma 1. And then pi comma 0. And then 3 pi over 2 comma -1. And then 2 pi, which would be the last point, and that'll put me back right here. And that's back to 0. Okay, and what we're going to do is we're going to transform these 5 points, and then based on those 5 points, we can keep graphing the graph. Okay, this is y equals cosine of x, okay? And the 5 points that we're going to use for cosine of x is 0, 1, because when you take the angle of 0, the ratio of cosine would give you a ratio of 1, okay? Same thing over here with these 5, okay? An angle of pi over 2 would give you a ratio of 0, because at pi over 2, if you go around the unit circle, okay, at pi over 2, the x is 0, and the cosine ratio is your x over your r for that unit circle, okay? And then pi would put you at negative 1. That's that point right there, okay? And then 3 pi over 2, that's down on the negative y-axis, right? And x is going to be 0 there, so 0 divided by r is going to be 0, okay? And then finally 2 pi, and we're back at 1, and the whole thing starts again, okay? All right, so we need to know, we're gonna get to know these 5 points really well, okay? All right? Okay, let's go to our first example, okay? For example 1, I want you to be able to find the amplitude, the period, and the frequency of the function, and then you use the language of transformations to describe how the graph is related to y equals cosine x. And then I want you to be able to graph, using the 5-point method, I want us to graph 3 periods of this, okay? All right, so very first off, the A is 3. That's my vertical stretch, right? So that's the amplitude. And that's equal to the absolute value of 3, which is 3, okay? Now, your B value is 2, so you're going to multiply any horizontal length by 1/2, the reciprocal of 2, okay? So that would mean our period, okay, would be 1 over 2 because the reciprocal, and our normal horizontal period is 2 pi. That's the horizontal length it takes to repeat. So we're going to take this 1/2 and multiply it by 2 pi, because whatever the horizontal length is, it's going to be half of it. So now this is going to be pi. So my period is pi, okay? Now what's the frequency? So the frequency is how many of these are in one, okay, in one unit. So that is 1 over pi. And if we put that into our calculator, we get an estimation of 0.318. So we see about 31.8% of the entire wave, okay? And from 0 to 1, we'd only see about 31%, well, 32% roughly, okay? Or about a third of the wave we would see, okay, from 0 to 1. Now, again, that's not that important, okay? All right, I do this just because of physics, okay? All right, so now let's talk about the description, okay? So we've taken y equals cosine x, okay? So y equals cosine of x, that's the parent function, okay? And the 3, we're gonna vertically stretch it by a factor of 3, okay? So y equals cosine x is vertically stretched by a factor of 3, okay? Now what that means is all my y coordinates are going to be tripled. They're going to be 3 times what they were before, okay? All right, and then what does the 2 do? Okay, well, it's going to be the reciprocal of that. We're going to describe it through the reciprocal of that 2. So the reciprocal of 2 is 1/2. Okay, so when we multiply our x's by 1/2, that's going to cause them to move closer to the y-axis. It's going to cause them to compress or shrink towards the y-axis. So that's a horizontal compression by a factor of 1/2, okay? So this and is horizontally compressed by a factor of 1/2. Okay, so now we're gonna list the 5 points for cosine. Okay, so y equals cosine of x, and for y equals cosine x at when the angle is 0. Okay, the y coordinate is 1. This is the parent function. Okay, and then we move to a quarter turn, so that'd be pi over 2, and that'd be 0. And then at pi, the cosine function is -1. Okay, because we're on the negative x-axis. Okay, all right, and the x value would be -1, the y value would be 0, and r would be 1. Okay, and then 3 pi over 2, comma, and then that would be 0. And then we're back to 2 pi, the fifth point, right? And that would be at 1 again, okay? Now, what we're going to do is we're going to manipulate these 5 points, okay? And what are we going to do? Well, what we're going to do is we're going to triple all the y's. So every y you see here, we're going to triple. We're going to multiply by 3, okay? And then what we're going to do to the x's is we're going to half them, okay? So we're going to take a point, so, you know, like xy from y equals cosine x, okay? And the transformation that we're going to take is we're going to half the x's. So our new points are going to be half of x and then 3 times the y coordinate. Okay? So that would give me 5 points for y equals 3 cosine of 2x. So y equals 3 cosine of 2x. Those 5 points are now going to be half of 0, which is going to be still 0, okay? And 3 times 1, which is going to be 3, okay? And then half of pi over 2 would be pi over 4. And then 3 times 0 would be still 0. And then half of pi would be pi over 2. And then 3 times my y, so 3 times -1, that would give me -3. Okay? And then we're going to do half of 3 pi over 2, and that would be 3 pi over 4, comma, and then we're going to triple the y here, so tripling 0 would give us 0, okay? And then 2 pi, half of 2 pi would give us pi. And then 3y, okay, 3 times 1 would give us 3, okay? So there's 5 points that we can graph for y equals 3 cosine of 2x, okay? So I'm going to slide this up, so we're going to keep those 5 points, and then we're going to graph it, okay? So we have 0, 3, that would put me right here. Okay, now we have to look. Okay, right here is pi over 2. So this is half of this pi over 2. So this has to be pi over 4. So each one of these lines is pi over 4. Okay, so pi over 4 comma 0, that would put me right here. Okay, and then pi over 2, -3. So here's pi over 2. I'm going to come down to -3 and put a point there. Okay, and then 3 pi over 4. Okay, that'd be pi over 4, 2 pi over 4, 3 pi over 4, 3 pi over 4, 0. That put me right back here. Okay, and then pi, I'm back to 3. And you see how we have one full wave, okay, from 0 to pi. Now, we got to graph this, okay? Remember, these are going to be a little horizontal right here, and horizontal right here, and horizontal right here, okay? And they're just going to pass through here. So it's going to be kind of look something like this. Okay? Now that's one period, okay? So we just need to continue this, okay, across, all right, and graph at least one more period this way. So I need to be able to see 3 complete periods, okay? All right, so I'm right here at pi, I'm at 3. So then I'm going to come down the next pi over 4, and I'd be right here, okay? And then right at 3 pi over 2, I'd be down here at -3. And then this next one, which would be 7 pi over 4, would put me back to 0. And then 2 pi, I'd be back up here to 3, okay? And so I'm using the spacing of this, okay, to replicate it. Okay, so I'm going to come down and then come back up. Okay, so what I'm seeing right now is, and this should actually come back down like that. Okay. Okay. So how many waves am I seeing? How many periods am I seeing? I'm seeing 2 right now, right? So that's 1 and 2. Okay. I need a third one, right? So I don't have any more grid to go 3 more. Okay. So I need to go back this way. Okay. And I did that on purpose. I'm going to make you do that. I'm going to make you go on the negative side of 2. Okay. So right here, I'm 1 away, right? So I'm going to be back to 0. So over here, I'd have to be 0. All right. And then right here at negative pi over 2, I'd have to be at -3. And then back up to 0. There's something happening at every pi over 4, okay? And then at negative pi, I'm going to come back up here and put a point, okay? And so it's right here at this minimum, it's a horizontal right there, okay? So we're going to come up and connect that. Right here, it's horizontal and comes down, okay? And we're now seeing 1, 2, 3 waves, okay? Or 3 periods. okay? And that's how you graph these, okay? So we have to know those 5 points, and then we use the transformation to get the new 5 points, okay? And then we graph those 5 points, okay? Hopefully this kind of makes sense and it's a little bit easy, okay? But you do have to know those 5 points for sine x and cosine x, okay? And we'll do tan x and cotangent x later on, okay? All right, so let's go to example number 2. Same question here, okay? But it's going to be sine, okay? And we have negative. I'm going to rewrite this because I want to know what I'm dividing by 3, but I want to know what I'm multiplying x by, okay? So this is -2 sine of, okay, dividing by 3 is the same as multiplying by 1/3. So really this is 1/3 of x, okay? Now, what's the amplitude? Okay, that is the absolute value of this a value. Okay, so the absolute value of -2, which is 2. So that means my amplitude is 2. My period, okay, now my b value is 1/3. What's the reciprocal of 1/3? That would be 3. So I'm going to multiply all my x's by 3. Okay, if I multiply my x's by 3, they're going to get bigger, right? So that's going to be a horizontal stretch. So my period is going to get stretched by a factor of 3. Okay, so this is going to be 3, because that's the reciprocal of it, right? Times 2 pi. Okay, so I'm always multiplying by the reciprocal of 2 pi times the reciprocal of your b value. So that's going to give you 6 pi. Okay, so my new period is 6 pi. Okay, so what's my frequency, right? So my frequency, I want to take 1 unit, okay, 1 unit on the x-axis, and I want to know how much of these fit into that, right? So that means I'm going to have to divide. So 1 divided by 6 pi, okay? That's the frequency. Now, what is that as a decimal, okay? All right, so you put that in your calculator, 1 divided by 6 pi, and it gives you 0.524. So we're seeing about 52% of the entire wave from 0 to 1. Now, we don't have 0 to 1 on our grid, on our x-axis, okay? But if you were to graph only 0 to 1, you'd see about half of a wave, okay? And that's all, okay? All right, so let's talk about the description of this, okay? So what does this negative do? Now, it's working on the outside of the sign, right? So that means I'm multiplying my y's by a negative. Okay, that would mean positive y's become negative and negative ones become positive. So that's a reflection over the x-axis when that happens, okay? So we're going to take y is equal to sine of x, the parent function, right? And we're going to reflect it. So is reflected over the x-axis. Okay, that's what the negative does. Now the 2 is the vertical stretch, okay? So it's reflected over the x-axis, comma, vertically stretched by a factor of 2. And then what is it done horizontally, okay? Now we got to always say in terms of the reciprocal of b. So the reciprocal of b again is 3, okay? So that means I'm going to multiply my x's by 3, which means that would cause a stretch horizontally, okay? So we see vertically stretched by a factor of 2 and horizontally stretched by a factor of 3. Okay, so let's write the 5 points for y equals sine of x. Okay, so y equals sine of x, when x is 0, right? When this input, this angle is 0, the output is the ratio for sine, and the ratio for y over r at angle 0 would be 0, okay? And then pi over 2, comma 1, and then pi, comma 0, and then 3 pi over 2, comma -1, and then we'll be back to 2 pi, because that's our fifth point, right? And at 2 pi, we'd be back to 0. So we go up, back to 0, down to -1, and then back up to 0, okay? All right, so now we're going to graph y equals -2 sine of 1/3 x, right? So what does that mean? We're going to take the x and the y coordinate on y equals sine x, and what we're going to do to that is we are going to multiply the x's by 3. So this would be 3 times x, comma, and what are we going to do to the y's? We're going to multiply the y's by -2. So it'd be -2 times y, okay? So that means y equals -2 sine of 1/3 x, or x over 3. Okay, the first point, I'm going to triple my x. So my first point is going to be 0. And then I'm going to multiply my y by -2. So 0 times -2 is still 0, okay? And then I'm going to take the next point, which is pi over 2 comma 1, and I'm going to multiply my x by 3. So that becomes 3 pi over 2, comma, and I'm going to multiply by y by -2. So 1 times -2 would be -2. Okay, then the next one, I'm going to take my x and multiply by 3. So that'd be 3 pi. And I'm going to multiply my y is 0, so I'm going to multiply that by -2. So -2 times 0 would be 0. And then 3 pi over 2 times 3 would be 9 pi over 2, comma, and I'm going to multiply my y here by -2, so that would make 2. Okay, and then 2 pi times 3 would give me 6 pi. And then -2 times 0 would give me 0. And there's my 5 points that I can graph for y equals -2 sine of 1/3 x, okay? All right, so I'm going to go to my graph. I'm going to slide this up a little bit. Okay, so right here is 6 pi, okay? And if you look, okay, from here to here is pi, so this would have to be pi over 2. So this is 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2, 6 pi over 2, 7 pi over 2, 8 pi over 2, 9 pi over 2, and so on, okay? So we have 0, 0, right? And the next point is going to be at 3 pi over 2. So this is pi over 2, 2 pi over 2, and this would be 3 pi over 2, and I'm at -2. So I'm going to go down to -2, which would be right here. Okay, and then I'm going to go to 3 pi, which would be right here, and I'm going to be back at 0. Okay, and then 9 pi over 2, okay? So so I got to count by pi over 2. So 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2, 6 pi over 2, 7 pi over 2, 8 pi over 2, 9 pi over 2, right there, right? 9 pi over 2, 2. So I'm going to go up to 2 and plot that point right there. And you should see it equally spaced too, okay? And then 6 pi is back here to 0, okay? So if this point's over here, like it's not lining up, like it's not balanced, like, and it looks kind of funky, okay, make a note of that and go, hey, did I make a mistake somewhere? And just take a look, okay? Because everything, there should be some symmetry and balance to this, okay? All right, so I know right here, this is my minimum, okay? And I know I have to go horizontal right there. And this is my maximum, I'm gonna have to go horizontal right there, okay? So it's gonna look something like this, right? And this one's gonna go down. And then right here, it's gonna go down. Okay, so so if you count 1, 2, 3, every 3 grid lines, I'm gonna plot a point, okay? So 1, 2, 3, 3 grid lines, right? And what am I gonna have to do? Well, this graph would have to go down, right? So 1, 2, 3, I'm gonna have to go down to -2. Okay, and then 1, 1, 2, 3, right here at 9 pi, right? Well, what's gonna have to do? Well, that's another minimum, right? So I'm gonna have to come back up to right there, okay? And I missed it because my pin was in the way. Okay, now, how much do I see? How much of the wave do I see? I see 1 wave, right? And then this is only a half. So I'm only seeing 1.5 waves right here. 1.5 full periods, okay? So, okay, I need to see 3 periods, right? So how am I gonna get the 3 periods? Well, I have to graph this side of it, okay? So every 3 grid lines, 1, 2, 3, right? A point is happening, okay? So in this case right here, at this third grid line, 1, 2, 3, right? Which would be negative 3 pi over 2, we're going to be at positive 2 right here. Okay, and then 1, 2, 3, then I'd have to be back at 0. And then 1, 2, 3, I have to be at negative 2, which would be right here. And then 1, 2, 3, and I'd be back at 0 at negative 6 pi. And then 1, 2, 3, and I'd be up at positive 2, right there. Just checking to see the balance, okay? And then 1, 2, 3, and I'd be back here at negative, or at 0, okay? All right, so now we're gonna be horizontal right there, horizontal right here, because that's my minimum, my max, and these are like hills and valleys, okay? So that's a hill right there, a rolling hill, not a peaky hill, okay? Not a mountain, a hill, okay? All right, so it's gonna roll up to right there. This one's gonna roll down, and I like to do these in pieces, okay, like that. And then this one's gonna go down like this, and this one's gonna go up like this, okay? So I see one period, 2 periods, 3 periods, okay? And I have 3 periods for this trig function, okay? And that's how you graph these by hand. And it's not, I honestly, I really don't care about you graphing these by hand, to be honest, okay? What I care about, by you doing this, you start to understand how these functions look and you have a better understanding of it, okay? I'm really trying to get you to understand the behavior of these, not that you can graph it. That's just a way of getting you to understand it, is by you graphing by hand, okay? All right, so that's example number 2 for this, okay? And we're gonna do very similar things next week with cosecant and secant and all of that, okay? All right. Okay, guys, so that's it for today. I'll get the assignment sheet out and I'll tell you what the assignment is, okay? Okay, so what I want you to do is I want you to do we already did the graphing trig functions 3, okay? And then the worksheet GTF 4, okay? Now, some of these are gonna make you think, okay? I've given you the graph and I ask you what's the, and I ask you, and I tell you the function, and then I've asked you what are the window settings. So I've given you a graphing calculator, like picture, and I've asked you to find like what's the min, what's the left side of the window, what value is that, and what's the right side of the window, okay? And you can tell that by looking at the amplitude, okay, and the period of it, okay? So you're gonna have to calculate the period and go, oh, it's gotta be this because I'm seeing 1.5 periods of it, okay? All right, from 0 to the right side of the graph, okay? All right, so it's gonna make you think, okay? And that's okay, all right? It's gonna make you understand these that much better, okay? All right, guys, so just do GTF 4, okay? And I'll see you Monday. All right, you guys, take care. Bye.